it's interesting to consider modifications to quantum mechanics. I think there's a reason that it has to be linear, and it's also true in classical mechanics that it has to be like things have to be linear in probabilities. And this is also true in classical mechanics. If I flip a coin and if it's heads, I put a planet on the right, and if it's tails, I put it on the left, then the evolution of that probability distribution of planets has to be the same whether I know what the value of the coin toss was or if I don't know what the value of the coin toss was. And so linearity just reflects the fact that the dynamics of these two planets, sorry, of the one planet, whether it's on the left or the right, should somehow not depend on whether I know the value of the coin toss and where I put the planet. And that's just because if physics does not obey that law, then what that means is that the evolution is different based on a counterfactual. The evolution when the planet is on the left somehow depends on where I would have put the planet had the coin come out with a different result. And we know that, physics cannot depend on what I would have done had the coin been a different value
Yes.
because it was heads and it doesn't matter what I would have done had the coin come out tails. So that linearity in quantum mechanics and for classical mechanics, if I have probability distributions, reflects that fact. And I think that feels like a fact about probabilities that we just don't want to mess with because you're really messing with some deep stuff, I think, that goes well beyond a kind of is embedded very deep in just what it means to consider probability distributions rather than anything to do with quantum mechanics or anything else. So even if I were to come up with some, theory that is more fundamental than quantum mechanics, it should still obey this kind of a linearity, that on probability distributions, it should not depend on whether I know the value of the coin toss. Sorry,
I
that was a bit of a TED talk, I think.